Now, there's actually another method we can use for drawing strip footings. Earlier, we said we'd draw one strip between each pair of columns, like a strip along grid line G, then F, then E, and also vertical strips along grid lines 7, 8, 9, and so on. So instead of going through the usual draw rectangular floor option, creating each strip manually, and then editing the coordinates of all the corner points, well, there's a shortcut. In SAFE, you can first draw a centerline using beam elements, and then convert those into area elements that represent your footing strips. Here's how it works. You start by drawing a beam along the centerline of where your footing will go. Later, you'll convert that beam into a surface with the correct width and depth, like a 1.5 meter wide, 1 meter deep strip, for example. Now keep in mind, at this stage of the design, we usually don't know the exact width or depth of the strip footing. So these are just rough assumptions. Once we run the analysis and design, we can go back and adjust them if needed. So what do? We define a dummy beam, one that matches the dimensions of our strip footing, and draw it between the columns. Let's go ahead and define that. From the Define menu, go to Section Properties, then click on Frame Sections. You'll see an existing section called Beam 1. We can just modify that. And now let's match the properties to our footing strip. Set the material to conch. Then set the depth to 1 meter. That's the thickness of the footing. Next, enter the width. Let's assume 2 meters for now. Click OK, and then OK again. Alright, now from the side toolbar, choose the Draw Beam tool. A new window pops up, but we don't need to change anything. The default settings are just fine. Now click from this point to this point. Then again, click from this point to this one. Basically, just go ahead and connect all the columns using these dummy beams. They'll act as placeholders for the strips, and we'll convert them into area elements in the next step. First, we need to select all these beam elements. You can either click on them manually or use the menu, go to Select, then select Properties, Frame Sections. Choose the section we used earlier, Beam 1. That'll highlight all the beams we drew. Now with all of them selected, let's convert them into area elements. Go to the Edit menu, then Edit Frames and choose Convert Beams to Slab Areas. And just like that, they're all converted. Now the endpoints of these new areas might not be perfectly aligned, so we'll need to clean them up in the next step. But before we do that, let's go ahead and delete the original beam elements. Here's how. Again, go to Select, Properties, Frame Sections. Remember, all these beams were drawn using the Beam 1 section we defined earlier. Now that we've converted them into slab areas, they're no longer categorized as Beam 1. They've automatically been turned into elements with a section called None. So if I try to select Beam again and click OK, look, nothing gets selected. Why? Because those original beams have already been converted. Instead, now we can select all elements with section None. These are the leftover frame elements that we no longer need. Select them, then just hit Delete. And now we're left with a clean model. Only area elements, no beams. Exactly how it should be for a strip footing model. Okay, let's now clean up the geometry of these area elements, especially at the ends where the corners might not be perfectly aligned. Now, we just need to snap these nodes to the ends of the foundation strips. So, I'm selecting these nodes, and we want their x coordinates to match this point right here. It means we'll set them to 0.5. The same goes for the nodes on the other side. We'll move them to x equals 37.5 to match the boundary on that end. And again, we'll do the same for these nodes over here. One important thing to keep in mind is this: when you're drawing strip footings in both x and y directions, you might wonder if they should overlap at the intersections. Ideally, it's better if the strip elements don't overlap. They should just meet at the joints. But if they do overlap, it's not a big problem. SAFE will automatically consider only one of the overlapping areas in its calculations. However, there is a small catch. If you apply any type of surface load on your foundation, like the dead load from floor finishes or a live load from a parking area or any other kind of live load, those overlapping zones will receive that load twice. Basically, SAFE treats it like both overlapping areas are carrying the same load, which will overestimate the actual demand. So, to avoid this, it's better to remove overlaps whenever possible. For example, we can move these nodes slightly upwards. Same here with these nodes. I'm adjusting them to clean up any overlapping areas. And that's the general idea. Just go around the model and fix any overlaps if you see them.